This was the design and analysis of algorithm, the first question I did on past papers. So for this question, it's a classic DP question where we have three parts and it asks it basically to design three parts of the algorithm, but almost all of them use like DP. So like it's definitely a heavy DP question. So let's get started. In part A, we're asked to describe the knapsack problem with repetition, showing a dynamic programming that finds the optimal value, and show that the algorithm has running time O in W, where N is the number of items and W is the capacity of the knapsack. So for part A, what I did was that basically I had a just describe the problem, right? Knapsack is just with repetition is where there are infinite supply of items, each with their own weight and value. You have a backpack that can carry at most weight W. What is the maximum value you can get? The time complexity of this is O and W because we inside our program we have our for loop. We go from 1 to W and then we go from a second for loop from 1 to N. Hence we go through W and N and then hence our complexity is O and W. And then we let item I have weight. Basically, when we're designing this algo, we just define Wi and Vi. So we're just going to have our input and output. And then we're just going to first initialize DP list with size W plus 1 with value zeros. Next, what we're going to do is we're going to set in to be the size of V, so the number of items. And then we have our for loop from 1 to W for I, from J from 1 to N. We're going to check the statement. If it's valid, I minus WJ is greater than or equal to 0, so we're not having index errors. We're just going to set the DPI to be equal to the maximum of the DPI and also the previous one, which is just subtracting the weight from that and then that value plus the current value we're adding of that item, right? See, it's pretty straightforward, and then we return W. So yeah, I should have said earlier in my answer, yeah, this question I lost a bit of marks because I did not see that. Um, it was I have to explain O and W, but it basically essentially because I have these for loops and then going from 1 to W and 1 to N, that's what I have. And in my correction here, I basically just wrote out that, yeah, if I sh was to do this question, I would have done recurrence relation is something like this, where I have my base case and I have my recurrence relation, which was just basically the statement that I just did. And then the time is O and W because, yeah, I go through the two for loops. Okay, moving on to the next part. I think part A was pretty straightforward because it's just a bookwork question. And then part two, we're going to just apply this in a different scenario. Suppose you have to find accommodation for n guests. There are H hotels available, and you know that putting K guests in hotel I would cost CKI pounds, where CKI is an infinite finite integer for every K smaller than or equal to n. Design a DP algorithm that finds the minimum cost of accommodating all the guests. So for part I, we're just gonna have this, right? So we're gonna try to initialize matrix of size n plus 1 and n plus 1. And then what we're gonna do is we know that if it's 0, then it's gonna be 0. If we have something of this case where we have no hotels, like we either have 0 or infinity for that, right? And now we kind of just go from our for loop. I'm I thought that for sure, like basically I had to go from 1 to H, going through all the hotels, right, one by one. I'm gonna add each hotel at a time and see what the previous thing was. And then I'm gonna assume that I have J people in total, right? If J people came, then what would have been the case? So J goes from 1 to N. Eventually I work up to N. And the next is if I was to fit K people inside my hotel I, what would it be? So K would go from 1 to J, right? Because J is my current population. So then I'm gonna go K is it's going to be smaller than when you go to J. So then I know that my DPIJ would be the minimum of my current value and whatever the previous value was. The previous value would just be the hotel before that. So 1 up to the hotel before that, which is I minus 1. And then what I messed up in was that I missed this for loop. So then it should have been basically how many people were staying beforehand, right? Like if I have K people staying in hotel I, it means that I have J minus K people staying in the other hotels. So it would have been J minus K. And then I would have to add the cost of staying at hotel I for that. So that would just be my cost. And then obviously in the end, I would return DPH of N, which basically means, yeah, I'm finding what the hotel with one up to A H included and people, right? That's what it means. And because I got part one wrong from here, part two was wrong because I thought that I had to go from one to H, one to N, so it's HN. But here, because I go through the loop, I have three for loops, then it would have been HN, and this one could be up to N, so it would have been OHN squared. So that would be the complexity. Yeah, for part two, I already did that. Basically, it's running time of your algo, yeah. So moving on to part C, an investment company offers in investments number one through N. For the investment I, the company guarantees a return rate of RIJ in year J. If DI dollars are invested in the investment I, then the return after year J will be this thing, where it's just multiplied together. Every year, investors can reinvest their money, initial capital, plus all the returns gained so far. They can decide to keep the money on the investments of the previous year, or they can choose to redistribute the total money in a different way, in which case they have to pay a fee F. Suppose that investor has initial capital of D dollars and invests them for Y years. The problem is to find the optimal investment plan. So in part one, we're going to show that there exists an optimal strategy that in each year puts all the money in a single investment. So yeah, it makes a lot of sense. Like if we have all of the return rates are like, let's go through it. So basically these were the condition, right? Invest in a single thing. So I just thought of it as this. If I have the returns to be R1, R2, all the way up to Rn, then the raw returns without considering the changing fee would be R1, P1, R2, P2, all the way to Rn, Pn, where PI is the percentage of the fund invested. So we're just going to, without the loss of generality, assume that R1 is the largest. Hence, for R2, P2, since R1 is greater than R2, then R1 minus P2, um, R1 P2 minus R2 P2 is greater than or equal to 0. So that means that we can optimize for R1 for all P2. And the same reasoning apply for OI, hence the best investment strategy is to invest in one, which is R1. Um, the changing fee will not make a difference as it does not change the optimization logic. It's just a constant amount to be paid for the optimal, otherwise kept. So that's what I thought at the time. And to be a bit more rigorous in this, what I say, I think it's better just to write it out as fully as like this is the sum of the things. Then I'm just gonna it's gonna be less than or equal to the sum of the maximum for sure, right? And then for that, if it's maximum, I'm just going to extract out the R in front, and then it's going to be sigma. And then no matter what, if I subtract the fee, it wouldn't change it. So hence, I can have this. Okay, so for part two, let's move on to part two. Design an algo that finds an optimal investment strategy. Okay, so for this is just kind of another DP question, right? We're just going to define money to be D, year remaining to be Y, current R to be equal to 0. So we're just going to take a for loop from Y from 1 to year remaining. Our maximum R is 0, our maximum R index is 0. We're going to go from another for loop from 1 to N. If our maximum of R is smaller than our thing, then it means that like our maximum should be this value, our maximum index should be updated to that. And then we have a if statement that checks if it's the first one, right? There's kind of no kind of going about this. We're just gonna automatically uh, set that to be the case because it doesn't have a changing fee cost, right? If it's the current R is equal to maximum R IDX, so we're still at the same one as the previous year. So there's no doubt we're just gonna pick this. So we're just gonna times the money by that interest, and then the current thing would just be the current thing, right? And then otherwise, what we would do is just compare and take the maximum of the thing, either changing and minus the fee, or otherwise just taking the current interest of that. And regardless, we're just going to return the money. Say because we have two for loops, we go from one to year remaining and then from one to n. So basically what we do is year remaining times d. So our complexity would just be yd or yn. So it would just be an n squared algo. Yeah, and for part B, yeah, this was a proper written up thing where this is a recurrence. Okay, just a note is that yeah, for part A, the time complexity is this because I go through the two for loops. Yeah, I think in the correction I even didn't write that, so it's better that like I just kind of say this ahead of time.